It's long been understood that the basal ganglia play a role in motor movements. In general, most motor movements are actually driven by the motor cortex outputs to the spinal cord and onto the muscles. But motor cortex outputs also go to the basal ganglia. The basal ganglia influence the thalamus, and the thalamus influences the release of the motor cortex outputs to muscles. Furthermore, motor movements aren't the only behaviours that are influenced in this fashion. There are a number of parallel paths from the cortex through different parts of the basal ganglia and thalamus and back to the cortex. These involve different cortical areas, different regions of the basal ganglia and thalamus. The path from the motor cortices goes through the putamen and is strongly involved in motor behaviours. Another path, involving the cortical frontal eye fields, is strongly involved in directing eye gaze and therefore attention, and it involves somewhat different regions of the striatum and the GPI-SNR and so forth. There are two more paths involving the prefrontal cortex that perhaps we can assume play some role in higher cognition. And the path through the ventral striatum seems to be involved in rewards, but it probably has some additional roles. All these 5 circuits utilize different parts of the striatum, the globus pallidus, the substantia nigra, the thalamus, and the cortex, but the basic circuit design is similar. You can see the cortical areas that are primary from these 5 circuits in this diagram. Other cortical areas that provide striatal inputs to one circuit are generally strongly interconnected with the primary area. There's also an interesting characteristic of the connectivity between the cortex, the striatum, and the midbrain dopamine neurons. This illustrates those midbrain dopamine neurons, and they can be arranged along a continuum with the SNC at the bottom right and the ventral tegmental area at the top left. Different regions of the striatum provide inputs to different dopamine neurons along this continuum. The most dorsal part of the dorsal striatum provides inputs to the most dorsal part of the SNC. The more central part of the dorsal striatum provides inputs to a more ventral part of the SNC. And the core region of the ventral striatum provides inputs to the more dorsal region of the ventral tegmental area. And finally, the shell provides inputs to the most ventral part of the ventral tegmental area. The midbrain dopamine neurons also project back to the striatum. But to make the diagram a bit less confusing, I'm drawing the striatum again on the right and illustrating the return projections over there. The return projections are again segregated in a similar fashion from dorsal to ventral. However, if you look closely, the region of the midbrain dopamine neurons that gets inputs from the shell projects back to the shell and also to the more ventral part of the core. The region of the midbrain dopamine neurons that gets inputs from the core projects back to the more dorsal part of the core and the more ventral part of the central striatum. The region of the midbrain dopamine neurons that gets inputs from the central striatum projects back to the more dorsal parts of the central striatum and the more ventral part of the dorsolateral striatum, and so on. So there's a kind of spiral of connectivity in which the region of the striatum that sends outputs to a particular band of the midbrain dopamine neurons gets inputs from a band of midbrain dopamines that is somewhat ventral, somewhat offset from the band that gets its outputs. There are also inputs to the striatum from overlapping cortical areas with the same dorsal to ventral arrangement. Motor and premotor cortex outputs tend to target the dorsolateral striatum. Premotor and dorsolateral cortex areas target the central striatum. Orbital and medial prefrontal cortical areas target the core. And mostly orbital cortical areas target the shell. So there's a spiral structure in the arrangement of the connectivity between the cortex, the striatum, and the midbrain dopamine areas. And one final interesting point. The amygdala, that we'll discuss later, has some cortex-like regions, and these regions also project to the shell.